Hello and welcome to my showcase of NeuroFluxGenesis, my self-developed AI system, and the game I made to test the AI, um, simply called AIRacing. That is what you can see here. And yeah, this is running now like half an hour, I think. Um, so the cars are pre-trained if you want so. Um, because it's a mode that I activated at the moment where it's really, yeah, where the AI has to handle difficult tasks. So yeah, as you can see, um, the AI is controlling several cars. At the moment, it's 100 cars. They're running on a racetrack. I developed an algorithm for that creates functional racetracks like Formula One racetracks with an algorithm that creates out of a hash different tracks. So it was necessary to be sure that the AI can train in different situations on different tracks. Yeah, what's so difficult to handle now for the AI is that I activated the weather simulation and also night and day cycle. And yeah, the cars are calculated physically correct by the Unreal Engine. So they are it's chaos that handles all the physics calculations, and so yeah, the cars can drift. You can see it because that's always the question at if the AI can learn to drift in curves, and yeah, it has to because the weather situation changes. So at the moment it's raining, and the friction will get lower. So yeah, they slide more, and the AI has to handle that. And it also can start to snow. I think it already started to snow because snow is showing up here on the street. So yeah, we changed the perspective now. So yeah, I have the camera system added, so you can change the view. So that's the view on the street out of the car, and yeah, you can see it's a day-night cycle, and yeah, the procedural generated track. It's simply only forest biome at the moment. Um, yeah, but you can see the cars handling the track without problems, and that's what I'm very proud of. The cars in the best circumstances can learn to handle the track without crashing to the virtual walls. They are around left and right of the track. You can't see them. Um, yeah, without crashing after late maximum 10 generations. So yeah, but now there are in a different situation because of the weather happening and different situations on the track. They also have to fight against wind. You can see it that there is wind at the moment, like this. It's 50 kilometers per hour at the moment, and the direction is in degree. So the direction changes and the wind changes and pushing the cars for sure to so they have to fight against it. Yeah, you can see at the moment 16 cars die at rate in 1 minute, so they crash. Yeah, because we are in training now. Yeah, there are some other information you can see. The fitness, for sure. There are other fitness functions that add or for the males on the fitness that is necessary to for evolutionary neural network to learn, because it has to know if some decisions are good or bad. So that's why there's a fitness function. Yeah, we can show. I can show you another information. Yeah, that's the biggest or the most important thing. You can see how many calculations there are at the moment for the AI. So at the moment, the AI is calculating 61 billion calculations per second on my GeForce RTX 4060 with 16 gigabyte of RAM. Yeah, and how does it add to this much or big calculation number per second? That's why that's because there are 100 cars that are all calculated by the AI with a neural network for every car. Yeah, you can see that's the current weights, so that's the same as neurons. No, that's not right. The weights are the connections between the neurons. So that's synapses in, I think it's in English, like, yeah, the connections between neurons in the human brain too. Yeah, there are some other information, how long the feed forward needs to be calculated, so it's no in milliseconds. Yeah, they're always happening the crossover when a car finished the track or crashed, so then offspring is generated out of the parents. Yeah. There are other information. There's a mutation rate at 0.1. That means that 0.1% of every weight is shifted when there's a crossover after a car crash. So that's how the AI is learning things, because the weights were randomly shifted, and yeah, that's the randomness leads to the thing that everything is in the right position, every value, the weights leveled, so that together with the fitness function, it can know which weight is leveled fine and which is not so fine. So that's randomness, but at the end, the best values will be found. So that's how an evolutionary neural network is working. Yeah, you also need the mutation strength. That is how much the weights are shifted. So it's up to, in a random way, up to 0.1 or minus 0.1. So that's that. And yeah, you also need the biases. That's how a neuron is activated by the activation function. That is yeah, the normal way neural networks are calculated. They always need an activation function. I prefer ReLU, or in a better way, leaky ReLU. And for the output layer, it's 10H. I think it's called 10H, TNANH. Yeah. So that provides 10H provides values always between -1 and 1. And the cars are only having two outputs, or need only two outputs out of the neural system, neural network. Um, and it's mainly braking and throttle and steering left and right. That's it. And into the neural network at the moment are going a lot of information. So for the main thing, it is this one. Yeah, that are raycasts that measure the distance to any obstacle. In this mode, not to other cars because it's ghost mode. They can, um, wow, it's maybe I should darken it a little bit. In the dark, it's night, it's very lighty. Yeah, you can see there's the virtual wall that is hit by the raycast, and that's how the AI is getting information about the surroundings. So it's the distances, and they are normalized. That's one of the biggest yeah, things I had to learn when creating the AI. Um, Input should be normalized, so they are all like from 0 to 1 or minus 1 to 1. So yeah, I normalize all the distance measurements between 0 and 1 and put that as an input neuron to the AI. So for people that are not knowing how an evolutionary neural network is working, so yeah, you have a lot of so-called input neurons where the AI is getting data about what the AI can know. Um, I will turn that off. Yeah, we have another mode like this. This is TV mode, I would say. Yeah, we can close the information here. Yeah, so the input neurons, that's how the AI is getting information about the surroundings, I already told. And they are put in the so-called hidden layers. So a hidden layer is are neurons that are put into a layer structure. So you can decide how many hidden layers you want to have for your neural network. You can say if you have more neurons per layer and more layer, then the AI is capable of knowing and learning more patterns. So yeah, you can say it's more clever if there are more neurons, but it's astonishing that the AI can learn to drive a track. I tried that with only 8 neurons in one hidden layer. So I was really astonished by that because at the moment there are a lot of neurons. So it's 10 layers with 128 neurons that are calculated at the moment. That's why there's such high number of calculations per second. Yeah. Um, okay, let's finish the topology of evolutionary neural network. So after so yeah, we have the hidden layers, and they are all connected from left to right. Every neuron is connected to the next layer with every other neuron in that layer. So this yeah, that's the normal way evolutionary neural networks are built. There are other ways, but that's I think it's the best way because others are parts of that. So of course there are recurrent neural networks, and I added that too to the AI, but I don't use it at the moment because I'm not sure if it's getting better results, or maybe it's bugged at the moment because I don't think that the results were better. Recurrent neural networks would lead to some kind of memory. So yeah, neural networks with recurrent neurons are able to have a kind of memory. So that's a simple way to tell. Okay, so the topology. Every neurons are connected to the next layer, and at the end there's the output layer. And the output layer, I already told, are only two neurons, and that is what the magic in the hidden layers is. A lot of matrix calculations. It's the simplest way to explain that. Yeah, and it's changed by the crossover. The weights are changed. So as I told, the neurons are connected with weights, and the weights are numbers. Let's say also between -1 and 1, and they yeah, the matrix calculation leads to, if you want, the values in the neurons. Yeah, and there's the activation function. If the value is higher than the activation function, then the value, oh no, it's getting loud. So, because it's stormy weather now. Yeah. The activation function, then the neuron is activated and is used as you would think or say. It's yeah, I have to do it in a not so scientific way. Yeah, at the end there's the output layer, and you have your activation function 10h, and that leads to numbers between -1 and 1. So in this case, -1 means steering full left, and +1 steering full right, and yeah, the other output, +1 full throttle and -1 full brake. Yeah. So that's what is happening here. The AI I developed, I call it NeuroFluxGenesis. I hope that it's capable of, yeah, to make, the plan is that the developers can use it for their games, and let the AI take the decisions that previously has to be scripted for NPCs. So I think it's because of the pure processing power, it is able to get to calculate a lot of inputs and a lot of outputs, so the decisions. And I created the simulation here for the racing simulation to see how capable it is to steer or to control decisions. And at the moment, it's only 2 decisions. But I also created Pong, and it's controlled by the AI. So yeah, I will showcase it in future. It's the simplest way, and I will show how to add my NeuroFluxGenesis plugin for the Unreal Engine to your project, and how you can add the neural network to your decision making of your NPCs. Yeah, so that's it. We can try and see what we have here. So there are other things I started to implement. You can change the mutation rate on the fly, the mutation power. There are other information, the training type, which crossover method you prefer. Then there are the mutation processor. That is how the mutation is calculated. It could be fixed, so at the moment it's fixed with a 1%, 10% of every weight will be shifted or mutated. Then there's with a sinus function, it's getting up and down, so that you have phases where the mutation rate is higher on phases where it's lower. So the AI will try different things out with a higher mutation rate. Random, yeah. Success level is interesting. So if there is no faster car than before for a different time, then the mutation rate will rise. And if there's a new best car, then the mutation rate drops to 0 and starts to rise again. So that's an interesting one. There are other ones you can think, well, yeah, it's not so important to see that. Yeah, you can restart the simulation here. What else we have? Yeah, we have the what is it here? Yeah, it's the button. That's the mode you have. Now it's in ghost mode. You can change that on the fly to normal mode. Then the cars will see the other cars and collide with the other cars. But yeah, your guess. No, it's loud again. I have to make that not noisy. Oh, it's louder. Okay. I don't know how to audio mix it here in the right way with OBS. I'm not so professional at that. Yeah. Okay, we do it like this. So if I click it, oh no, it's too loud. Okay, there's the ghost mode. That's what is active. Then the normal mode and training is where the cars can see other cars and collide with them. But it's yeah, the training time is much higher because the AI has to do a lot of more work to learn and guess how other cars are behaving and so on. Yeah, I will add. I added a lot of things to make that possible. That the AI is learning that too, but yeah, it needs time to train that. Okay, then there is the not training mode. That means it takes the best car and only the best car is chosen. So there's no mutation. That is, if you want, to the real mode where the cars give all their best. At the moment, they try things out and can crash because of the high mutation that is happening when they start. Then there is the spawning mode. We can show that. Maybe we can, yeah. You can save the AI, all the models with pushing the button here. Yes, I do that now. That's why it was not fluid. And now I can load it, and then the simulation starts with the loaded neural network. So yeah, and that's, I changed the spread over track side, so that means that the cars are spread over the track and started from the side. That is needed for training in normal mode, because if they start at one point in fixed mode, then they will collide with each other, and that will not work. So yeah, we can see if I push training normal mode now the other cars will see every car will see other cars, and yeah, you can see that they all, yeah, they try to try not to crash into other cars because of the measurements. Now you can see there's also the red raycast now because they can see the other cars, and yeah, it's working fine, but not as good as it should, because there is much more training is needed So sometimes they crash into the wall because they have different data they have to handle now. But yeah, for the beginning, it's not too bad, I think. Yeah, this car decided to move to the right, but crashed into the virtual wall then. Yeah, well, you can see they brake a lot more because they have more obstacles now. Yeah, it's interesting. It's working fine. Okay. I can change the seat of the track. So as I told you, let's say we want a track. I know that number because there's a great curve right after the start. Or let's say we do the one thing. You can type in whatever you want. It always creates new tracks. And you can set the size of the track. So yeah, 50,000 is nice. So the track is around about 3 kilometers long. If you make that higher, then it's longer. And yeah, you can, this button is for surroundings. So if you push that button, then there's no surroundings. It's for testing because it's created faster. Yeah, then cars per track. So at the moment it's 100 because it's nice for performance. And how many laps they have to solve. Yeah. Then there's other modes here. Last location is where it's crashed. It gets again on the track. Spread over track means the same as spread over the track side, but it's in the middle of the track. It's not good because other cars will crash because they spawn on the track here. You see it. And yeah, if the car spawns directly in front of another car, then it will crash for sure. Yeah. So let's do that again. And what else we have? Racing mode, yeah, that's the normal mode how cars are put on the track. So at the start line, and yeah, we can do it. Well, why not? So let's see. You can change also the cars. So I'm jumping through every car. It's no problem. So now we are cars. Yeah, and they start in a row and have to solve the chaos there. Yeah, but it's doing great. So I'm happy about that. Not too bad for without training. Yeah, it breaks, but crashed into a wall. Yeah, funny. Yeah. Okay. Okay, so let's do fixed again, but then we have to go into ghost mode because every car spawns in the other cars. Yeah, let's do another track. So it's simple. You only push that button and a new track will be generated. Let's see. You don't know the track, so it shouldn't be a difference for you. Okay, I hope it won't crash because normally I test it in Unreal Engine, but that is packed here and compiled, so it's a real game, not in the engine. So yeah, seems that it's not working. What is happening here? Oh, it works. Okay, let's see what's going on. Yeah, there's as I told, there's a curve directly after, and let's see if that's a fantastic thing. They don't learn the tracks; they learn how to drive. Funny. Yeah. Okay, and now let's see what happens if the cars will start new. So there's no AI trained. And what will happen then? Let's say a random one. Let's say I never tried, I only push some buttons here. And then that's how I do it. Yeah, I will generate that track. Then the cars will have their AI already be trained because it's not resetted. So I don't know which track will be generated. I hope that my algorithm to create procedural tracks is fine and every seed will work with a track that it's drivable. I don't know why it's taking so long. So yeah, of course, I have to do a lot of optimizations. Um, from time to time, I have some days where I optimize. Yeah, so now we are in the situation that the AI is on a really new track, and now we change that to that and restart the simulation. Let's see. I'm not sure if that's working because, yeah, I never used that really because yeah, it's a fatal error. Okay, so yeah, um, that's where we can see what I have written here in C++. So it's a lot, I think. Wow, where we are. So let's see. Okay, here's here's the AI and the whole. So that's all the code for the AI, and then there's the code for the racing game. Yeah. So the AI is more interesting. What do we have here? Yeah, there's the C++ code, mainly NeuroFluxGenesis. It's a lot, you can see. So that's handling all the things that is necessary to calculate everything in C++. And then there's the more important part. I'm running now this feed-forward kernel. And that's the AI on the GPU do things different, and maybe it's not too bad to do things different. Maybe other people would say, yeah, what he does is normally, and everybody does it, but he doesn't know that everybody is doing it. Maybe, but maybe not. So yeah, I came up with the idea to have this one here. It's I call it the list of fittest. Of course, there's a word for it in a professional neural network scientific way that is elitism. So I have added some kind of elite neural networks. I call it the list of fittest because every car that crashes and is better than the worst car in this kind of list, it will be added to the list. And that leads to the thing that only the best cars survive. So they get these cars that are in the list of fittest are chosen to be parents for the child, for the offspring. So there's some algorithm I did here in the hello here. So you can see it here. No, I'm too maybe I should put there, here it is. So I say, yeah, I create a list of fittest with 200 entries, and that's how the parents are chosen. So it's 10% of the list of fittest at the end, because I have a shrink system. So it shrinks the great big list of fittest to a smaller one in a percentage after crash. So now I say shrink immediately, but I can say here, yeah, you can see it. Yeah, after generation reaches 10 or something. But now, because it's the AI is so clever that it does not need a big population, only at the beginning, and then a small population is fine. Yeah, we are talking about population. Yeah, and what you can't see now is what happened already here. Okay, yeah. The AI is not good at learning at the moment because I added some experimental new feature that leads to the problem that it's not fitting at the moment. Let me overstate that for a second, because I wanted to show you how fast the AI is capable of solving the first lab. So let's see what's going on. Yeah, for sure. I made a mistake here. That's why, because I let the developer choose which activation function for which layer they want. So you can control every layer with your own activation function. And that's 10 from the previous topology, but we don't have 10. We have 1, 2, 3, 4, 5, 6, 7, 8. So we need 8 activation functions. 5, 4, 6, 7, 4, 4, that's 8. What? Yes. So yeah, of course it can't work because it calculates more than there are neurons in it, and that it wonders me that it's not crashing. Should crash normally. Okay, maybe that was the problem. We have to compile it again. I love the Unreal Engine, that it's all possible in Engine. Yeah, let's see. But I added some other feature that I started to talk about that can lead to the problem that the AI is not learning as fast as it did before. We will see. There's the other thing. Yeah, because it's learning on 10 tracks at the same time, it's hard to find out the right values as fast as if it learns only on one track. So yeah, I will show you that there are really more than one track now. So that's the track I always starts with 1002. And there are the other ones. Yay! And they're totally different. And there's a bug also with the placement of the trees. Yeah, well, no problem. I can fix that. But yeah, the trees have no collision, so the cars can drive through it. So that's not a problem. Yeah. And where's the start here on this track? Yeah, there it is. Okay. So yeah, it needs more time because it has to handle a lot of different data, but at the end it will work. It needs more time. Okay, but we will see how fast, or we want to see how fast the AI learns the track. So I have to do it in the simplest way with one track and a population of 100. If you then make 200 in live mode, so if it's compiled, then it's capable of doing 200 because the physics are calculated. Yeah, the Unreal Engine has more processing power if it's not in the Unreal Engine because it has to calculate a lot of things in the background for the engine, not for the game. Yeah, okay. But we can compile that again in game. So there's only one track and 100 cars from one starting point in ghost mode. And let's see. Okay, we open the list of fittest and another. No, we can have a camera where we can move wherever we want. And let's see. Oh, what? Yeah. I have to do it in a slower manner. So yeah, the first car. No, there's a better one. So it's already really clever. Maybe it's also already capable of solving the track, it seems like. What? I need another camera system where the camera follows the car. Yeah, I really don't know. Yeah, okay, that's the part where it's crashed. Okay, now it's dark, but yeah, they have light. Let's see what he's doing. It's the same. So they have to learn how to solve this pattern here of the track of the curve. Another one. Yay! He's better. And he's faster. But he crashed somewhere here, I think. Yeah, in the night you can see what they're doing here. Yeah, I think that's the one who will win the first track. Yay! And let's see what this time is. Yeah, 55 seconds. That's really fast. And the second one coming in at 51. So it's even faster. And that's with generation 10, and the first car was in with generation 8. So yeah, I don't know why really I don't know why they are so good, because normally they need much more training. Yeah, and now you see that everybody gets um, the AI, the weights are leveled out in the best way, so they behave like each other from after some time, and that's where mutation comes in, because it changes the weights. And yeah, they are not clever, and the list of fittest you can see have entries here. Let's see. There's a lot of information I have to delete again. So the list of fittest is now 38. It will shrink further. At the end, it will be only 10 of the fittest cars. And yeah, offspring is chosen randomly from this. At the moment, it's always father's or mother, if you want to. One parent is always the first one, and the other is chosen out of the other 10. Yeah, and that leads to very clever cars. And yeah, we are in the mode that they learn to drive the track in the fastest way, not in the safest. Uh, if you want them to force to drive in the safest way, you only have to change that number here. Because if you say, yeah, you have to drive 100 laps, then for sure the car that solves 100 laps is, because of the fitness function, the best car. And all cars learn from the best car. So yeah, it needs to be good to solve 100 laps. And yeah, yeah, you can see what's happening now, because I have the weather system on. It's very, the friction is going down here. I show that the friction is now getting worse, lower or something, and that's why they slide more. And the AI has to learn how to solve that problem, that it's now more sliding. Let's see how they slide. Can you see it? Yeah, they all, I think they start to try to drive in a slower way. That's what happened after I trained the cars that I showed at the beginning. So yeah, the two of them found a way to come around this curve. So now these cars will be the best. And yeah, I have to add some epoch system. That's also a system that is used in neural networks and evolutionary neural networks. But I can simulate that with saving and loading. So it's the same. So now I save everything. Everything is resetted, and a new epoch will start. So the best cars now will be added to the list of fittest. And now they have to solve the problem with low friction here. Yeah, but I added an epoch system, but it's not activated, so we can use it too. But yeah, it's for, I added that for the mode where the cars have to learn to overtake other cars and so on. Yeah. Okay, that's it. It's a long video, and I hope I didn't annoy you with the maybe not so professional way to present the AI and the game. Yeah. Again, I want to be more professional in future, but I have to decide to work at the simulation or work for good video presentation. So yeah, I'm on my own. I'm solo developing. So yeah, if you're interested in my project, please consider talking about or asking me something about it, and maybe we can team up, because I have so many things I would like to add to the neural network. But yeah, time. You need a lot of time to do it and do it in the right way. So the next idea I wanted to add, I planned for months now, but don't have the time because there are other things I would like to add always. Simpler ways, simpler things. But a convolutional neural network I would like to add, and maybe exchange the raycast with the convolutional neural network outputs, or have the convolutional neural network adding their outputs or its outputs to the inputs of the neural evolutionary neural network. I don't know, I would try to test both because it's a simple thing to add a convolutional neural network, to have the opportunity that the cars or the AI have eyes. Because in Unreal Engine, you can easily get out the depth buffer of a camera. So I can add a camera to the cars in front, another one, and read out the depth buffer, and then you have information. Normally, maybe you have seen that before. The depth buffer is shown in a black-white picture where near objects are white and far objects are darker, or vice versa. Yeah, and if you're doing that and reducing or only make a picture, a texture if you want so, with let's say 64 times 64 pixels, then you can add that to a convolutional neural network and use that as an input, the outputs of this as an input for the car, and that should lead the AI to see the track in the whole. So not only at some points, like it is in a raycast, there's only one hit to a wall, but they can see the whole wall. And the AIs, the convolutional neural networks, can see the patterns and see when a curve is coming and so on. So I think that the AI would be much more capable of driving, for sure. And for you as a developer, you can whatever do with it. So if your AI has to see something, what comes up in mind for me, I always wanted to do an evolutional simulation, simulation about evolution, and yeah, and so maybe the creatures in your simulation can see that there's food in front of them or at the horizon or wherever. So the AI could learn how to go to this place and take the food and survive. Maybe. Yeah, that's one thing I would like to add, and that needs time. So yeah, as I said, I'm solo developing and would like to do much more, but it's not possible or what I wanted. So yeah, if you're interested in this kind of AI, please ask me. We can talk about how I can provide you with the code or something, or maybe not the source code, but yeah, it depends. Yeah, or we can team up or something like that. Yeah, what else is necessary to say about the neural network? Sure. It's an evolutionary neural network, I already said. It's very capable of very fast in calculations. It does not need any other framework. It's native C++ and OpenCL. That's why I did it, because there's no, as I know, no system for games. If there's a neural network we used, it's always used with PyTorch and Python. So you don't need Python, it's only C++ and OpenCL. It's a plugin for the Unreal Engine. Um, yeah, I for sure can do or change the code that it's only C++, not directly for Unreal Engine. I started that, but came up with the idea it would be a cool thing to have it as a plugin and maybe sell it on the Unreal Engine marketplace. Yeah. So yeah, it's native, and I found out that Unreal Engine Epic added some kind of neural network agents with, I think, 5.3 version, but they're doing it with PyTorch again, I think. I'm not sure, but I think it is also Python based, and you can train your AI agents, but you can't not real-time train. This is real-time training, because you see it's real-time training at the moment. You can have that active in your game, so the AI is always learning from, yeah, let's say you're playing some shooter and the AI is controlling your opponents. Then the AI could learn from your behavior to survive. That's the idea that is behind NeuroFluxGenesis, because it's not a pre-trained one. Yeah, yeah, I think it's. I would like to have some AI in game that learns from my behavior and not from behaviors of people that trained the AI. Yeah, yeah, it was more like an elevator pitch now. Yeah, it's long and maybe annoying, but maybe it's interested. You are interested in more information about it. And for sure, I will make new videos in future. And yeah, I hope to do it in a more professional way if I have some support, friends or something. Because yeah, it needs time, and I'm not a professional cutter. Yeah. Okay, thank you for being here and not yeah, running away before the video ends. So again, thank you, and I hope I got you interested in this technology. Bye bye.